in experimental and applied particle physics, nuclear physics, and nuclear engineering. A particle detector, also known as a radiation detector, is a device used to detect, track, and/or identify high-energy particles, such as those produced by nuclear decay, cosmic radiation, or reactions in a particle accelerator. Modern detectors are also used as calorimeters to measure the energy of the detected radiation. They may also be used to measure other attributes such as momentum, spin, charge, etc. of the particles. Description: detectors designed for modern accelerators are huge, both in size and in cost. The term counter is often used instead of detector, when the detector counts the particles but does not resolve its energy or ionization. Particle detectors can also usually track ionizing radiation. If their main purpose is radiation measurement, they are called radiation detectors, but as photons are also particles, the term particle detector is still correct. Examples and types: many of the detectors invented and used so far are ionization detectors and scintillation detectors, but other, completely different principles have also been applied, like Cherenkov light and transition radiation. Historical examples: bubble chamber, Wilson cloud chamber, photographic plates. Detectors for radiation protection. The following types of particle detector are widely used for radiation protection, and are commercially produced in large quantities for general use within the nuclear, medical and environmental fields. Gaseous ionization detectors, Geiger-Müller tube ionization chamber, proportional counter, scintillation counter, semiconductor detectors, dosimeters, electroscopes. Commonly used detectors for particle and nuclear physics: gaseous ionization detectors, ionization chamber, proportional counter, multi-wire proportional chamber, drift chamber, time projection chamber, Geiger-Müller tube, spark chamber. Solid-state detectors, semiconductor detectors and variants including CCDs, solid-state track detectors, Cherenkov detector, rich scintillation counter, and associated photomultiplier or photodiode, avalanche photodiode, Lucas cell time-of-flight detector, semiconductor detector, silicon vertex detector, transition radiation detector, calorimeters, microchannel plate detectors, neutron detectors. Modern detectors in particle physics combine several of the above elements in layers, much like an onion. Research sites with particle detectors: at colliders at CERN for the LHC CMS Atlas Alice, LHCb for the LEP Aleph Delphi, L3 Opal for the SPS, the Compass Experiment Gargamel NA49, at Fermilab for the Tevatron CDFD0 Mu2e, at DESY for Hera H1 Hera B Hermes Zeus, at BNL for the RHIC Phoenix Phobos Star, at SLAC for the PEP2 Barbar for the SLCS LD, at Cornell for CESR Clio CUSB, at BINP for the VEPP2M and VEPP2000 NDS NDCMD for the VEPP4KEDR. Others: MECO from UC Irvine. Under construction for ILCCALICE. Without colliders: Super Cameo Canda, Amanda, CDMS. On spacecraft: Jedi, AMS.